Hello Year 7 and welcome to our first online lesson. We are working on fact trees and prime factorizations today, but before we start I've just got a few revision questions that I want you to do to make sure that you can do all of today's exercise. So here they are. We've got question 1, write all the factors of 60. Question 2, write the first 5 multiples of 6. And question 3, I want you to simplify each of these using the index laws, and I don't want you to actually write 8 for this. I want you to write 2 to the power of something with the power. I want you guys to pause the videos, take out some paper and actually do these, and then we're going to work through these questions together. Okay, I hope you've paused your videos and you've got your answers in front of you too. Let's go through the answers. Question 1. We're going to write out all the factors of 60. So, the factors of 60 are 1's a factor, 2's a factor, 3's a factor, 4's a factor, 5's a factor, 6 is a factor, 7, no, 8, no, 9, no, 10, yes, 11, no, 12, yes, 13, no, 14, no, 15, yes, 20, yes, 30, yes, and 60, yes. And something to note here also is that all of these factors come in pairs. For example, 6 and 10 are a pair, 5 and 12 are a pair, 4 and 15 are a pair, 3, 4, 5, I was just counting the lines there, and 20 are a pair. I'll do a new symbol for 30, 30 and 2 are a pair, and 60 and 1 are a pair. So bear that in mind because that's going to be a hint for solving the puzzle that I'm going to give you at the end of this lesson. Okay, question 2. You were asked to write out the first 5 multiples of 6. Well, that's pretty easy. You've got 6, 12, 18, 24, and 30, just because it's 6 times 1, 6 times 2, 6 times 3, 6 times 4, and 6 times 5. It's just the times tables. Alright, question 3, and we'll call the first one 3a. We wanted to know what was 2 times 2 times 2. I hope you guys know it's 2 to the power of 3, because this little number at the top here, this just keeps track of how many times we times the number together. Alright, 3b. Let's do it. We're doing 2 times 3 times 2 times 4 times 3 times 2. So here we go. We've got 2 times 3 times 2 times 4 times 3 times 2. Well, I can count my 2's. I've got, let's count them up here. 1, 2, 3 2's. I can see that I've got 2 3's and a 4 left over. So let's write it out. We've got 2 cubed times 3 squared times 4. But let's take it one step further. That's 2 cubed times 3 squared, but 4 is actually just 2 squared. Not 4 squared, but 2 squared. So 4 is 2 squared, and now we've got 2 to the 5 by 3 squared. Okay, let's do our last one, and we'll just put it over on this side of the board down here. So we've got 3c. And that was, I'll just double check, 3 squared times 5 cubed all squared. So here we go. 3 squared times 5 cubed all squared. Well, I know that's just going to be 3 squared times 5 cubed times 3 squared times 5 cubed. But that's just going to be, let's see, 3 squared times 3 squared is 2 3's times together. times 3 squared times 3 squared. So I've got 4 3's all times together in these two combined. So that's going to be 3 to the power of 4. And the 5's, I hope you guys can see it's 5 to the power of 6. The reason is we go 5 times 5 times 5 times 5 times 5 times 5 is 6 5's all times together. And of course that means we just add these two 3's here. 3 plus 3. By our index laws, we add them to get 5 to the 6. The even faster index law, you can see you go 3 is here. 2 times 2 is 3 to the 4. And 5 to the power of 3 times 2, we times these two together. Okay, so that's our review. Now let's look at our question. What we're going to do today is we're going to see if we can write 360 and we're going to break it down to its prime factors. So we're going to see what number it's actually made of. So we're going to go 360 and I'm going to do a little tree here like this, and I want to write two factors of 360. 10 and 36 look good to me. Then I'm going to break up the 10, 5 and 2. And 5 and 2 are both prime numbers, so I can't break them up anymore. Otherwise, I'd just be going 5 and 1, 5 and 1, 5 and 1 forever. And now I'm going to go down here, so I'll do 6 and 6. If you wanted to do 3 and 12, you definitely could have. 2 and 3 and 2 and 3. And we get our prime factorization is 2 cubed. Let me count. 1, 2, 3. 3 squared by 5 times 3 squared times 5 times 3 squared times 5. Now, I didn't have to do 10 and 36. I could have done it like this, for example. I could have made a really, really unbalanced tree. So I could have done 360 is 2 by 180 is 2 by 90 is 2 by 45 is 3 by 15 is 3 by 5, but you can see we've actually get the same prime numbers. 2, 2, 2, 3, 3, and 5. So of course we have the same numbers here, 2 cubed times 3 squared times 5. And I've just thought of a really interesting challenge for you guys. I want you to have a bit of a think about this, okay? I want you to think about how many factors 360 actually has. And I wanted you to see, can you work out a way to look at this, the prime factorization of 360, and work out how many factors 360 has without actually counting them, going 1, 2, 3, 4, 5, 6, and so on, okay? So, see if you can think of a way to work out how many factors 360 has just by looking at this prime factorization. Alright, I want to show you a second way to do a prime factorization now, and that's repeated division. So I'm going to start off with my 360 again, and I'm just going to rub that out. I want to write it a little bit higher because I don't want to run out of space. So here's my 360, and what I'm going to do is I'm going to divide it by 2. So I divide it by 2, and I'm going to put my quotient down on the bottom here, and I get 180. Then I'm going to get my 180. I'm going to divide it by 2, and I get 90. I get my 90. I divide it by 2. I get 45. I get my 45. I divide it by, well, not 2, but 3. And I get 15. I get my 15. I divide it by 3. And I get 5. I get my 5. I divide it by 5. 5, and I get 1. I guess that means I'm done. So then if I look at these numbers down the side, 2, 2, 2, 3, 3, 5, I get my prime factorisation again of 2 cubed, because it's 2 times 2 times 2, times 3 squared times 5. Just a very important note with these numbers down the side, we want it to be a prime factorisation, so we want all of these to be prime numbers we're dividing by, okay? We want them all to be prime numbers. It doesn't do us any good to put a number like a 10 in here, because then I'd have to divide the 10 by a 5 or a 2 later on to break it down. So we want this column of numbers to all be prime numbers. Okay, so let's now move on to our next thing. Our next thing is a preview of algebra. Last year, we found that the students who saw a little bit of algebra actually did far, far better in algebra when they started the topic in term 2 or 3. So I just want to each lesson just show you a little bit of algebra just to get you used to using these symbols. They'll also come in handy in the maths challenge and maths enrichment. So my first question, question 1. I'm just basically counting things, and I'm counting x's, okay? So I know that 2x is x plus x. So what I've got here is x plus x, and that's just 2x, because x plus x is 2 times x. So I've got x plus x plus x. Well, x plus x plus x is 3 times x. And I can just write 3 times x as 3x. I don't need to write the times sign, okay? So if x was 6, for example, this number would be 18. 3 times 6, it wouldn't mean 36, 36. And then I go, all right, plus my 2y. There it is, plus 2y. All right, question 2. Let's see. I've got 5 a's, and if you want to, you can imagine it as a plus a plus a plus a plus a plus a b. Then I take away an a, and I take away 2 b's. You don't have to write it out like this if you don't want to. So a plus a plus a plus a plus a minus a means you had 5 a's and you've taken 1 away, meaning you've got 4 times a, 4 lots of a, and plus b minus 2b. Well, let's think about this. If you have b and you take away 2b, if I just take away b, I have plus b and I just take away 1b, well, I've got 0. I don't have any b, whatever b's counting. But then I take away a second b, so we need to remember that we've actually lost an extra b. So what I do is I say it's going to be minus b or minus 1b. So I'll start off by writing minus 1b, because that's just like a positive 1, and I can even write a 1 here. It's just 1 minus 2, which is minus 1. And I don't actually need to have the 1 here, because if I've just got a b on its own, I can write it like this, as just b, that we automatically know there's a 1 in front of it if we write b by itself. Okay, so it's 4a minus b. Something that we can't do here is we can't go, oh, well, that's minus 3ab or anything like that, because we don't know how big a is and how big b is, so we can't combine them. And if we did combine them, if I was going to combine them and I wrote something like this, ab, well, ab means a times b, and we're not timesing a and b together at all, so we don't write that. All right, the next one of our algebra preview is question 3. Maybe you've already had a go and have raced ahead. So I've got a times a times a cubed, and I'm plussing on b squared here. And the big thing to know here is I've stopped my working here, okay? I'm not going to try to go a cubed, b squared. I'm certainly not going to go ab to the 5 or anything like that, because I'm not timesing the a's and the b's together. I'm plussing this separately to this. I'm not combining them with the times. And of course, I hope you guys know that we do all the, where am I here? I do all the a's together and the b's together because these are timesed, and then I've got a plus here, so that's just our BODMAS, order of operations. Okay, we'll do a bit of algebra most lessons just to get you ready for it when we do it and are used to seeing it for your problem solving. Okay, the next thing I've got for you guys is a puzzle. Now, what I have on this side is 100 light switches or doors. They can be whatever you want. We'll call them light switches. Now, all of these light switches are off, okay? So every single light switch is off. And I've got 100 people over this side. Now, the first person, he or she, they are going to go through and they're going to flick every single light switch on, right? So here we go. The first person's going to go and flick switch 1, switch 2, switch 3, switch 4, all the way, switch 99, 100. They love flicking light switches. The second person, and this is my second person, they're going to flick every second switch. So they're going to flick switch 2, switch 4, switch 6, all the way through to switch 98 and switch 100. The third person, now the first person turns them all on. This person's going to be turning half of them all off, well, half of them off. However, the third person, when we get up to them, they're going to just be, and this is person 3, going to flick switch 3, switch 6, switch 9, and so on, all the way up to switch 99, all the multiples of 3. Yeah, it's an exercise in multiples. Now, what switch do you think the 20th person is going to flick? And I'll just put my 20th person over here. Person 20 is going to flick switch 20, 40, 60, 80, and 100. Person 50, there they are, is only going to switch, flick switch 50 and 100. Person 51, and that's person 51 with the big 51 over their head, is just going to switch, flick switch 51, because the next switch they'd want to flick is 102, but there's only 100 switches. So everyone bigger than 50 only gets to flick one switch. And if a switch is off, they'll turn it on, and if a switch is on, they'll turn it back off. So they'll just change the switch when I go when they touch it. Now, if all 100 switches start as off after all 100 people go through, the question is going to be how many switches are on at the end of this. So if you like, you can post your solution and reasoning in the comments below, and maybe either the YouTube comments, but maybe actually better the comments in the Google Classroom, the link to the Google Classroom where I've linked this from, just so you're using your education email accounts. Okay guys, that's it. The lesson's gone on for almost 20 minutes. So the homework is to do from Cambridge, Year 7, you're going to do exercise 11D and questions 1 to questions 12. I have uploaded a homework sheet for you on the Google Classroom. And to submit your homework, you need to take a picture of this or a PDF scan, and you need to submit it in your class's Google Classroom. Not the whole grade's Google Classroom, but in the class's Google Classroom to your class teacher who'll be checking it. And also, don't forget, during when your class is timetabled, you need to log on to your class's Google Classroom and mark your name off the roll. Okay guys, thank you very much. That was the first lesson.